Objective 7, Rational Functions, Part 1b. We're going to talk about right and left-handed limits here. We've already talked about limits in the past, but important calculus concept is a right and a left-handed limit. If we have limit as x approaches 3 halves, x plus 1 over 2x minus 3, this little plus, it's a superscript, normally doesn't belong there. You're used to putting a plus in front of a number. Well, this is limit terminology. It means we're approaching 3 halves from the right. And if we have x approaches 3 halves with a negative superscript, it means we're approaching 3 halves from the left. And if we look at this graph that we've already constructed, which side we approach from makes a world of difference. As you're approaching 3 halves from the right, this shoots off to negative infinity. As x is approaching 3 halves from the left, it shoots off to negative infinity. So in this case, approaching from the right goes up to positive infinity. Okay, with the different functions, entirely possible that this would approach a number. So for instance, if this graph kind of did this, for instance, and that's 3, then this limit from the right, the answer would be 3 if it approached 3. But it isn't, so it goes up to positive infinity. That's how we describe it. In this case, as x approaches 3 from the left, what happens? This goes down to negative infinity. Okay, now here's 4 limits. You have limits like this in your packet, so 2 of these we already did, and these 2 up here we'll talk about. X approaches infinity. What happens as x gets larger and larger? Well, it approaches this horizontal asymptote. It gets closer and closer to 1/2. Okay, so this is 1/2. Now, x approaches negative infinity. Pay attention to that little negative there. We're headed to the left, indefinitely far. We're still approaching 1/2 just from underneath. We'd have like 0.49, 0.499, 0.4999, and this answer is 1/2. These 2 limits are just nothing more than horizontal asymptotes. X approaches 3 halves from the right. Okay, you can do it visually again. It's headed up to plus infinity. And x approaches 3 halves from the left, it's going down to negative infinity. And that's all there is to this objective. I just want to give you one more example. It's slightly different. Let's suppose, in fact, we have f of x equals 2 over x minus 3. Well, we can do a slight rewrite in this function. You can call it 0x plus 2 over 1x minus 3. And then we can find the vertical and horizontal asymptotes. The horizontal asymptote, okay, this horizontal line is y equals 0 divided by 1, or 0. Just simply divide those 2 numbers. That's otherwise known as the x-axis. Okay, so this is going to be approaching the x-axis from above and below on either side. And the vertical asymptote, that's just the same. X minus 3 equals 0, x equals 3. I'm not going to complete this example, but x equals 3 is here. And the vertical asymptote, this is 3. The horizontal asymptote is this dotted line right here. Just to make it vivid. Okay. And of course, we will have the same sort of behavior. It's going to be a graph like this. Sometimes it's like this, sometimes it flip-flops. Just all depends on the signs of these coefficients up here. And of course, we can figure out these 4 principal limits as well. So That's all for this one. We will be back shortly with Objective 8.